Hello, this is Jeff, and I'm going to demonstrate today the setup for this CNC piece that was provided by a student. We have RhinoCAM 2025 open. This is the setup that I received, so we have a setup containing one profiling operation. It's using the flat 1/4 inch diameter compression bit, which you can see here in the tool palette, and they actually want to do kind of a 3D shaping of an object. So if I zoom out a little bit, here is the piece up here, and what I'm going to do is a 3D operation that will put a side kind of slope on there. It's not going to be a perfect slope. They'll need to sand it down a little bit in the finishing stages, but we can get pretty close. So one of the first things I'm going to do, just click off that so I don't see the paths anymore, is I'm going to position this three-dimensional piece in the same spot that they have their other piece set up. So I'm just going to hold Alt and make a copy of that. We'll rotate it real quickly. There, and then I'm going to move it from this corner down to this corner. And so now it should be in alignment with the path which or the curve that defines its outer profile. We're still going to use that outer profile path, so I'm going to leave it there. I can see from their tool palette that they've got a few tools that are in addition to what we consider our standard tools. These three at the bottom, the 10 tools at the top, the 6 flat mills and 4 ball mills, those are our standard tools. So we're going to use those today. But look for the most updated tool set if you can. So let me see what we can do here. I'm going to unload the tool library. Because one was used in an operation, it's still going to persist there. And I'm going to load a tool library, which is the more current one. Currently, we're using this one here. The 6-digit number in the back is the date. So this was made on January 26th of 2026. So I'm going to go ahead and open that. Replace. We're going to go ahead and say yes. So there is a duplicate in here now. Wait. I'm just going to double check. There is not a duplicate in here anymore. We're going to double check that this is the updated version. So you can see here that this particular operation needs to be regenerated. So we're associating it with the new tool that is in fact tool number 5. We're going to get our slightly updated feeds and speeds, and then we should be good to go. I'm just going to save that for now. And we'll revisit that in a little bit, because I think that we're going to want to be a little bit more thoughtful with the placement of our tabs and bridges, so that they are not in the the joint here. So you can see there's one kind of awkwardly tucked in this corner that would be very difficult to clean up. Not impossible, but it would be difficult to clean up. We'd prefer to have the tabs kind of on the ends of these pieces. So we'll revisit that one anyway. So here are our tool palettes. So the first thing I want to do is actually focus on this 3D operation, and then I'll go ahead and show you how to put tabs and bridges in specific locations, and then we'll do the the final profile and post from there. Okay, another thing I noticed is that there's no work 0 within this setup, so we're going to want to add a work 0. Sorry, this was, if you double click on the setup, you see the basics of the setup itself. I just want to select it and then go to machining operations, work 0. I'm going to set this to the stock box, low SZ, and southwest corner. I'm going to click generate. I should mention I already did take a quick look at the stock box itself. So here is our stock box. If I double click on that, you can see that it is located at the origin, that the stock box is in the positive Z area. Its dimensions are 48, 96, 48. And we're just going to be using this last little bit of it. Actually, each student in this class, or each group in this class, was allocated a 4x4 piece of 1/2 inch plywood. Nominally 1/2 inch, but it's actually 0.48 thick. So I'm going to go ahead and update that, and you can see the stock box is a little bit smaller now. For the purpose of making kind of a representation at the end of the process for our staff to have a visual aid along with the packet they get, I'm going to draw a new rectangle too. So I'm going to rectangle, first corner is 0, and then 48, 48, just so we have some concrete geometry there. And then I'm going to drop some dimensions on there as well. So 48 and 48. Ta-da. Okay, so we have our setup here. First thing in the setup should always be a work 0, either linked to the stock box, or if there are multiple kind of setups in an operation, it could be linked to some geometry within the file. Not going to cover that right now. Okay, we do want to do some 3-axis operations, just 1, maybe 2 operations up in here to put the slope on this piece. So I'm going to return to the perspective view and zoom in just so I can see this a little bit better. We're going to do 3-axis. We are going to start with, typically one would start with a roughing operation and then a finishing operation. And as I'm speaking this right now, I'm realizing that I probably need to define the region here just as the sloped part and not the whole object. So let me do something real quick. I'm going to dupe edge, and I want to duplicate this edge and this edge, this edge, and this edge. Enter. Now I'm going to project to C-plane. Delete the input objects, yes. Enter. And now I'm going to join those together into one closed curve. Okay, so now I have 2 curves in addition to the 3D geometry, which I'll just hide momentarily. So we have the outer profile here, and then we have the duplicated edge projected to the C-plane here. So I'll just show the 3D geometry again. So I need that region so that I know, so I can tell the program where to do the 3-axis operation. So we'll do, we'll select the work 0, so the next added operation will be directly below it. 3-axis, we'll do horizontal roughing. Select curve edge regions. Should be able to just grab this one from below. And then enter. So this is simply defining an area within XY space through which it will essentially kind of depth map against the 3D object that is in that area. So we're then going to go ahead and select a tool. We're going to use a down cut bit for this piece. We'll use, say, a 0.25 down cut bit. We'll load the feeds and speeds from the tool. Our clearance plane will be the stock max Z value plus a certain distance. This was selected when I open this operation up, so that makes me think that that is the value that was selected on the profiling. We'll check that again before the end. Many of these things, when you add them in one operation and then subsequently start new operations, they carry over, clearance plane being an example, but that's not always the case. So we do want to look at each of the different pieces along the way. For our cut parameters, we're going to leave a certain amount of stock material on purpose. So that's this amount here. And we have some step over and step down in the next one. So it'll step over by a tool amount of 25%. That means 75% of the tool is going to overlap the previous pass. It's just going to go over a little bit at a time. I'm actually going to up this to, the number is smaller, but I'm going to increase the number of steps downward before we do the final profiling or finishing pass with a ball mill. So I'm going to do that at 25%. Might actually change the step over to 50. So you can see I just kind of reversed those. This was previously 25, that one 50, and I've kind of reversed what the defaults came in as. For engage and retract, we're just going to enter through a helical motion, and arc fitting is okay as long as we're doing it in the XY plane. We may wish to turn this off if we were doing like a finishing operation that is parallel finishing. We'll come to that in a minute. And we're going to leave the optimization off because I've seen more errors than I'd like to when this is turned on. It's a newer feature, so I'm going to skip that for right now. But I'll generate. So you can see here now we have a series of steps down that will be milled away. And I want to kind of roll this back a little bit. Left click on the setup, right click to pull up this menu, and then I'm going to go to simulate, and you can see what the simulation will look like. So I simulated the whole thing, including this profiling operation that needs to get fixed up, but you can see how it goes down in steps. We're going to further smooth that out with a finishing operation next. So I'll select the roughing here, go back to the programming operation. I'm just selecting this so that the next machining operation that is added gets added directly below. So we just did horizontal roughing, now we'll do parallel finishing. We still have the same drive region selected, which is good. We're going to want to keep that. Now we'll select a ball mill though, to get the least amount of scalloping or sort of kind of ridges along the way. We want to try to use the largest ball mill that we can because it has basically it's got a larger radius, and so that means it's going to be smoother toward the tip. Can't get into small areas, but here this is a wide open area. It's just a slope we're trying to put on there. So I'm going to use the largest ball mill that we have available, the 1/2 inch. Now I'll move over to feeds and speeds, load those from the tool. Our clearance plane, the last thing that I did was the stock max Z plus a distance. So we did that. So that popped up again. Remember I was saying some values carry over. In the cut parameters, now we're cutting to a stock kind of tolerance of 0, or to the edge of the stock geometry. Right here, I'm not going to go into great depth with the depth control or the step over amount. I have a pretty big bit, so this is going to be still a good number for that. Z containment is sometimes helpful. We could specify the lowest Z value as 0. Okay, or I'm doing the highest one. We could say 0.5, and we could specify that's the thickness of the material, and the lowest Z we could say that is to be contained within 0. So maybe we don't need the highest Z value, but you can see if the lowest Z is 0, then it kind of puts a floor through which to contain the bit. It won't cut into the table, that is. Linear entry and exit is just fine. I mentioned arc fitting here. It's already turned off, and that's good. I don't want to do any arc fitting in the X, Z, or X, Y planes. The machine doesn't like that. And for sorting, we can do minimum distance. It's not really a big thing here, but we'll go ahead and generate. And so you can see this is the back and forth pattern that is now created for this finishing operation. So let's have a look at this. If I simulate it, okay. Oh, interesting. So one thing I'm noticing right now, and I didn't notice previously, is that the thickness of their three-dimensional object is not the same as the thickness of the material. Okay, I'm just going to ignore that for a minute, and I'll have to follow up with the student a little bit later, so I don't have to completely restart this video at a later time. We're going to imagine that comes to the top edge. But you can see here in the preview that it doesn't. Okay, so this red line representing the top of the 3D object, and here it's removing material that I was expecting to be on the top surface. Okay, but we're going to set that aside for a minute, and we're going to do machining regions now. So within this machining objects window here where you find the tool palette, there's another area called regions. So I'm going to click on that, and then just kind of go over to programs so that I don't have as much of the stuff selected. I don't need to see the paths. I can actually hide the stock box for a minute. I'm going to hide this object as well. Okay. So machining regions are predefined regions where we can specify the location of like the tabs or the anchors that will connect a piece of geometry to the surrounding board. First thing will be to create a set. So here's just a basic set. And then I'm going to select some curves, and I'm just going to go ahead and get all of the curves that are representing the outer profile. And you can see that they now appear here. Whichever of these is currently highlighted will appear in green on in the display. So I'm going to start with curve region 1, which is in the lower corner here. And among the other buttons is manual bridge points on selection. So that's what I'm going to do right now. I'm going to tell it where I'd like the bridge points to be. And for these, because they're not very large objects, I'm just going to put them in the midpoints of the opposing sides. And I think that's probably going to hold them. Okay. I was more worried about this one where I saw, the tab in the mid space. Anyway, so I've selected 2 points. I'm going to hit enter to confirm, and then I'm going to jump down to the next one, and we'll repeat the process. Mid, okay, and enter. Make sure it's still there. Yep. Click on this, mid, and enter, or right click, that works as well. Region 4 is this on the far side. Mid, I know how to do it. Okay, and then the last one is the one up here. So this one, I don't want to put a tab along this sloped edge because then that doesn't make sense. We'd be kind of machining that away. So that's one for sure thing. We don't want to put tabs there. And generally, if we're just doing 2, that we might want to put them on opposing sides. So let's select midway on the short one here, and then I'm going to pick mid on the end of one of these joint notches in that way. If I wanted to, I could put a third one here maybe. I don't feel like I need to. So I'm just going to put the 2 on there. So I'll hit enter to select that. I'm going to go ahead and hit this button and just kind of hide that palette. So I'm just looking at this again. And now let's go into the profiling operation we were looking at earlier. I'm going to start by removing all because we're going to select them differently. We're going to choose them by predefined regions. And here we can just take the whole set. And so you can see they come in. And you can see that the red squares on each represent the placement of the anchor points. All right, so we're going to use the 1/4 inch flat compression bit. We're going to make sure the feeds and speeds are updated. Here, this is the way it was set up when the student prepared the file. So it had an absolute Z value of 0.25. But remember, when we looked at the stock box, the stock was located in the positive Z dimension. So if this were the case, it would run through the material during its travel motions, and we definitely don't want that to happen. So we want it to go a specified distance here, 1/4 inch above whatever our stock box definition is. So that was important to change. In the cut parameters, we're selecting an orientation for upcut using the compression bit. This is helping us to determine where the starting point is. We are using the inside versus outside method, and we're saying cut to the outside of each of these. Our cut geometry is located at the bottom. That is the bottom of the stock box. So we'll be approaching from the top. This is the total depth of the cut. We're going to do it in 2 sections. The rough depth needs to, because it's a compression bit, needs to be greater than the crossover value for where it transitions between upcut and downcut. On the 1/4 inch compression, it's 0.3, so 0.36 is good. And then we'll just finish it with a 0.12 finish and cut. We are going to want to plunge this one. Rather than entering a long path, we're going to select none for this one. This compression bit will allow us to plunge. Not all flat mills are intended to plunge. That is, they don't have a cutting surface on the end of the flat mill. They just have a cutting surface on the sides. So that's where you would want to enter a long path. but this compression bit does have a cutting surface on the tip, and so you're able to just plunge it into the material. That should not be confused with the ability to drill or plunge in that way. It's not that type of bit. So we already have the control geometry, so we want to do the advanced cut parameters. So here are the values that were given for the bridge sizes. I'm actually going to make them a little bit smaller. They had 0.4. I'm going to go ahead and make them 0.3. Here, the number of bridges is kind of irrelevant because it's going to follow the definition that was provided in the predefined regions. In the cornering parameters, they do want dog bone corners for these interlocking edge joints, and minimum distance sort looks good, and so we can now go ahead and generate that. And if we kind of rotate this around, we can see this is the new placement for the tab centered on that mark that we did earlier, and here on the end of that joint piece, so that we can take it off pretty easily. All right, let's go ahead and simulate this. All right, so there's the 3-axis work, and then it's going to go around and it's going to do the final profile cutting, and that's how we would do it. With, of course, the exception, as I mentioned earlier, that this geometry is not quite what I expected, so typically it would just come up and have a smooth edge, but I'll resolve that with the student, talking with them later. Anyways, thanks for watching. This was kind of a little bit more advanced setup lesson, but I thought that this was a really good file to use as a demonstration because of the variety of attributes that we needed to address. All right, thanks so much. Bye. Oops, I forgot to show you how to export this. So the last thing I want to show is you can left click on the setup, then right click to pull up the context menu and click on information. It will then show the sequence of operations within the setup, the tool number, information about the operation, and the total runtime for the setup. So as it's been programmed, this is anticipated to take about 6 minutes time. If I were sending this down to the lab to be cut right now, I would go ahead and print this. It would produce a cover sheet for our document, and then I would go on to also do a top view representation, which is why I drew the dimensions earlier. So I would print the immediate area in this way. I would just do portrait, vector, black and white, and what the contents of the file are. My computer always glitches if I try to send it directly to a printer, so I'll usually make a PDF first. So I would like print and drop it in my downloads or something like that. And so this would go along with the information cover sheet to communicate with our staff in the build lab what the CNC job is anticipated to look like. So those are two things there. And then finally, to actually produce the G code, left click, right click on the setup, and you would then go to post. I have already selected the ShopSaver Windows CNC ATC algorithm for producing G code. ATC is automatic tool changer. So here I'm going to click now on post, and I'm just going to throw it in that USB drive kind of randomly so I can show you. Here is the actual G code that we would be running for this file. Okay, so I would save this on the flash disk and include it within the packet. I might also do Control F and search for Z negative and see if there are any instances where there's a negative Z value. So here, Z negative 0 is still 0, right? So I suppose we'll probably see a lot of these throughout. But we'll also check it in the build lab to see, whether there are any areas where it would be cutting into the table. Anyway, that was the last little bit I wanted to add on. Thanks.